To my future investigators, I leave this diary so you all can know my story. So, first, I was born on July 22, 1822, to Anton and Rosin Mendel in what was then Heinzendorf, Austria. I spent most of my time living in a rural setting, with almost no possibilities of studying, until a local schoolmaster, who was impressed with my aptitude for learning, recommended me to a secondary school in dropout to continue my education. Obviously, the move was a financial strain on my family, and often a difficult experience for me. But I excelled in my studies, and in 1840, I accomplished to graduate from the school with honors. After that, in 1843, against my father's wishes to take over the family farm, I began studying to be a monk. I joined the Augustinian order at St. Thomas Monastery in Brno and was given the name Gregor. At that time, the monastery was a cultural center for the region, and I was immediately exposed to the research and teaching of its members, and gained access to the monastery's extensive library and experimental facilities. After some dropouts from several colleges, I managed to finish my studies in 1854. Then I began to research the transmission of hereditary traits in plant hybrids. It was a generally accepted fact that the hereditary traits of the offspring of any species were merely the diluted blending of whatever traits were present in the parents. However, the results of such studies were often skewed by the relatively brief period during which the experiments were conducted. Whereas my research continued over as many as 8 years and involved tens of thousands of individual plants. I chose to use bees for my experiments due to their many distinct varieties, and because offsprings could be quickly and easily produced. I cross fertilized pea plants that had clearly opposite characteristics, tall with short, smooth with wrinkled, those containing green seeds with those containing yellow seeds, etc. And after analyzing the results, I reached two of my most important conclusions. The law of segregation, which established that there are dominant and recessive traits passed on randomly from parents to offspring, and the law of independent assortment, which established that traits were passed on independently of other traits from parent to offspring. I found that paired P traits were either dominant or recessive, when purebred parent plants were crossbred, and I could saw dominant traits were always seen in the progeny, whereas recessive traits were hidden until the first generation, hybrid plants were left to self-pollinate. I counted the number of second generation progeny with dominant or recessive traits and found a 3.1 ratio of dominant to recessive traits. My conclusion was that traits were not blended but remained distinct in subsequent generations, which was contrary to scientific opinion at the time. The principle of segregation that I propose stated that during reproduction, the inherited factors, now called alleles, that determine traits are separated into reproductive cells by a process called meiosis and randomly reunited during fertilization. And finally, the law of independent assortment states that genes located on different chromosomes will be inherited independently of each other. However, in 1865, I delivered two lectures of my discoveries to the Natural Science Society in Brno, but my findings were misunderstood and people thought that I was only repeating the already known facts about heredity. And those comments managed to make me feel incompetent compared to the public opinion and to change my mind toward my findings or discoveries. After those unfortunate events, I returned to the school that I had been teaching for the last 14 years. Due to my duties, I wasn't able to continue my research.